Hello then. So recording has started. I guess we can get started with the third edition of the third the third show and tell sessions SyftBox. We have for some of you today is also the last day of the 30 days of Apple Code campaign. For some others of you, probably the campaign is already ended. I would love to hear from you on Slack how the campaign has gone and how it's going. Today we have a very packed session. The first thing I want to that's more an announcement. There's been there are some troubles with the syncing server now on SyftBox, which I'm aware of. Which means that if your API is relying very much on syncing, there may be delays on that. We will be posting updates on Slack and how that is going to work, and also solutions in the short term of things you can do in case. But this is just to let you know that this should be a problem for you generally only if your API, the workflow of your API, heavily relies on the syncing server. Otherwise, it's just slow, but it will get there. Anyhow, all right. So I presume that do we have Samir on? No. Irina, is Samir going to present, or just like is going to join later, or is not joining at all?
I joined. Sorry for that.
Oh, there you go. There you go. Okay, so I guess Samir, you're the first in the lineup to present, and you're going to be presenting the Ring HE app, I believe.
Okay.
Fantastic. Floor is yours.
Okay, awesome. Thank you, Valeria. So I don't know if some of you might have had a chance to take a look at this video we posted earlier in the week, but I'm going to just do a quick show and tell in this session, like this demo of the same thing. And so I'll start by briefly presenting a screen, which kind of goes over like the conceptual overview of what this app tries to do. So slideshow. So the goal is to be able to do secure aggregation over the SyftBox network. And so the simplest visual would be, this is the entire SyftBox network, but over some subset of participants, we would like to perform an aggregation. And in this case, it's very simple. It's just a number we want to add. But it's over a subset of people, and we want to do it securely. So there should be some notion of privacy associated with each user's data. So I'll jump into the specifics of the protocol. So this protocol is asymmetric in the sense there will be one leader who would sort of initiate the computation, and then everyone else is essentially a participant, and then everyone's data we would like to aggregate, but that's the only thing that should be revealed. So the way the protocol would work is the leader would set up a homomorphic encryption scheme. If you're not familiar with homomorphic encryption scheme, think of it as just any encryption scheme where you have a public key and a secret key. Public key can be public to everyone, like secret key will be kept secret, as the name suggests. And I'll talk about like what specific properties it requires. So given this, the leader would send the public key as well as like encrypted value of their own data to one of the participants. So this is so there are a few design decisions in this. Like one of them is sort of this computation proceeds in this circular fashion. But remember that all of these, this is just one example of how you can actually do this computation. There are many sort of other ways of doing. So we'll talk about that towards the end. So you send the public key as well as you send the encrypted data of the leader. And this is where I think a little bit about the encryption scheme would come in. So given the public key, this participant A can actually encrypt their own data with the public key. So that's a local operation. At the same time, they have access to the encrypted value of the leader's data. And the homomorphism comes in play here, where there is this notion of an addition operation, which allows participant A to actually just combine these two encrypted values into a single encrypted value, which holds the sum of the two values underneath. So essentially data of leader plus data of A. That's what would be encrypted. So this is a local operation that A can perform without having access to the secret key. So essentially not decrypting and adding them. And that's homomorphic encryption in a nutshell. To be very specific, this is a partially homomorphic encryption scheme, but we can talk about those other aspects towards the end. So once this is done, the participant A now does something very similar. So they will now package like the public key and this new encrypted value, and then send it over to participant B. And then this computation proceeds. So each participant kind of does the same thing. So participant B now takes what was passed over and would actually sort of embed their data in this encrypted value. So there is sort of this notion of a rolling sum, which is being passed around. And then at the end of like all the rounds, like the leader will actually have access to the encrypted value of the sum of everyone's data. And then the final phase of this protocol is just to be able to remove the encryption. So essentially leader, because they have access to the secret key, they'll be able to remove the encryption out of this and now publish like the total sum of the data in the clear. Like so, and this is again, like there are so many design decisions. Do you want the total sum of data to be available to everyone or not? Those are all different questions, but this is sort of the full flow of the protocol. And the code and instructions are here, like I think on the README. But given this sort of flow, let's try to do a live demo. So for that, I mean, if anyone would like to volunteer, I'll take a handful, given that the syncing is a little slow. We wouldn't do it over too many participants, but I'll walk everyone through the instructions. So first is I'm going to share a different screen. So if anyone would like to volunteer, like I would need you to have an active internet connection. I mean, you have like since you're on the call, but also have your SyftBox live and running, and then I'll walk you through the rest. So I'm going to share my terminal. So let me kill this. So the first command is I'm just going to run SyftBox locally. And so if anyone is thinking of participating, like you can do the same. So run your SyftBox client locally. And that's my live SyftBox client. So once that happens, you let me test out one other thing, which is actually I'm going to share my entire screen for a quick moment to test out so this is my data site. So I'm going to test out this new inbox feature where I'm going to broadcast the specific API that I'm interested in to everyone on this network. So I'm going to install the app locally, but I'm also going to look at this app, which is now local to my machine. And then I'm going to post it in broad. Subha or Nezio, can you walk me through where do I push this in broadcast?
Yeah, API is broadcast.
Okay, so I'm going to paste the app here. And what anyone who's looking to participate, what you would see is if you go to your data sites. And so Subha, I'm assuming like you would like to jump in with me. Then I'm going to.
Yeah, sure. So if you go to your data sites, and then inside your data sites, you'd already have a default inbox folder. And inside inbox folder is where this app should appear once the broadcast goes through.
So just for showing this publicly, I'm going to browse your data site. So you have this inbox here, and you see that Subha has this request for Ring HE app here. There is hidden folders, which is the approved and rejected one. But once Subha drags this Ring HE folder into the approved folder, it's essentially saying that she's okay with running this API. So
just dragged it.
Okay. Go for it, Nezia.
Just accepted mine as well. So
okay, awesome.
I also did it. And
okay,
yeah, cool.
Awesome. So I think given that I'll restrict the group to 4, like I think, who was it? Kasi, could you send your
Yeah.
email address here? Like, so that way I'll keep that in mind as we proceed.
Yeah. So it's in the chat, right?
Just send it over the Google Meet. Like that's fine.
Yeah.
Okay. So that's okay. So that's the first step. Like, so let's once that is done, like once we all have the API installed, the next step is essentially I'll start running the computation. But before we do that, we all need to have private data inside our data sites, or not inside, but like something that doesn't sync, but like we just need to have our own private data. So that will be so I'm going to open my data site, but just in VS Code. And if you look at the structure, right, like, so everything inside data site is what gets synced over the network, but there are these folders outside which don't really get synced. And so there is this private folder. That's where I'm going to create a new file called secret.json. And I'm going to add in my data here. So it's going to be data : 12. Or so I think I'm going to keep 12 here, but like this is how you're going to add your secret data into the aggregation computation. So I'm going to move this. I'm going to stop sharing my screen. I'm going to change my value. That way it remains private. But we'll test this over the network now. So
Do we need to create our own private, or you just created yours?
Private should exist by default. Like when you when that folder exists, you just have to create the file. But that's a good question, actually. Do you see the private folder on at the root of your data site?
Yeah, that should be there. Oh no, in the data set, right? I see API data, inbox, and public. There is no private.
No, you have to come up to at least 2 floors, like or 2 directory levels.
It's in the root of SyftBox folder. Not
Oh
in
yeah.
the-
Yeah, that private. Yes. Yeah, but that private, I don't have anything for this on ring TS, but for the CPU tracker I have. Do I need to create a JSON file there with data name or something?
Yes, if your private folder is empty right now, do you have a private folder?
Yeah, I have, but
Okay.
there is CPU tracker is there.
Yeah.
Because I have installed that.
Yeah, right where CPU tracker is, you can just add a secret.json file. Like, so create a new file in that, just inside the private folder. So not inside CPU tracker, just the same level as CPU tracker. And then you create a secret.json.
Okay, just give me a second.
Is going to be, I'll paste the syntax or whatever, like the JSON content, like, but just change the value to your own private number.
Okay. So name is secret.json, right? Okay.
Yeah. Secret.json. Subha, Nazio, are you ready with the secret? Yeah. Okay, awesome. So I think once, Kazi, I have your.
That's done.
You're done?
Yep. Yeah,
Okay.
I have it in mind.
Okay.
Cool.
So the next step is pretty much to kick off the computation. So one of us has to be the leader, like just for the sake of convenience, I will be the leader. So I'm going to share my screen, show how I kick off the computation.
Yep.
One question though I have is if you are willing to share a certain folder, like so just a window, that way it'll be easy for everyone else watching to see how the file moves as shown in like sort of the slide deck. So I'll mention which folder you need to share. So it's in data sites, your email.
Okay.
That should be a data slash. Subha and Nazio, this is the right path, right? Like what we should be looking at. This is where the.
Yep.
Yep.
So.
By the way, you're not showing your screen, so maybe.
Oh yes, thank you. Let me see. So I'll share my entire screen. Just it's easier. Could you find that folder, Nezio, Kazi, and Subha?
Yep.
Yep, found it.
So
Okay.
which folder?
The path is in chat. So data sites, your email ID.
Yeah. Yes, API data. Okay, sorry, I didn't look at. Yeah, I mean. Oh wait, why is that?
So,
Oh, sorry.
so
I
the
don't think so. My email, my API data,
mhm.
but there is no ring HE.
I believe you need to install the API though.
Right. Did you move the, yeah, actually, a good point, Valerio. Like, so did you move the ring HE from approved, sorry, from your inbox app?
Private?
So if
Yes.
you,
Yep.
you move this folder
Mhm.
into the approved.
Let me see again. So I am going to so ring HE is there, and
You can move it
yeah, I
again.
have moved it.
Okay.
I'll move it again. Yeah, suppose. Yeah, but
Okay.
yeah, it's already moved. Yeah.
Okay, awesome. Let's
It's
just
not
give it
moving
a
it.
minute. Like, I think that should be fine.
So just for in like as a as a summary of what's going on, essentially Samir what he's doing is like he's relying on the inbox API, in particular the broadcast feature of the inbox API, to distribute to everyone's data sets on the network these particular APIs. So
Okay.
he's sharing the computation of his ring HE API over the network, and which means that given the broadcasting nature of this communication, everyone is receiving a request in their inbox. Whoever is going to be accepting this request, this triggers the installation of the API immediately, which means that the ring HE API should be visible under SyftBox/API, which means you're running and you have installed and running the API. That when that is done, you now can proceed with the configuration, and so Samir now is going to be leading the computation, and you are participating to this computation. So you can create your secret.json file in your private folder, and then Samir will guide you through the next steps to actually use it.
Right.
Yeah, but yeah, that's true. But yeah, I have approved it like when we started doing this at first, but like 10 minutes ago, 5 minutes ago. But it's still like in my in my data side, I can't see this one. Is there anything else? And any step I'm missing?
Maybe can you share your screen so
Yeah.
we can?
Yep, definitely. Let's give me a sec.
And you're running the client, I presume.
Yeah, definitely. Yeah,
Okay.
still be running. Let me see. Yeah, it's running. Yeah, let me share this screen.
I don't see it in your API data.
Sorry.
Let's put a 1 minute cap to sort of debugging this in SEO, and then if not, we'll proceed with like just
Yeah.
the three of us, and then
Yeah, so you guys can stream this. So this is SyftBox. So if I go in data science, in the
API
inbox, in the API data, it's not there, right?
Right.
Okay.
So I'm in the inbox,
Right.
and ring AC is here, right? And I have already moved it here. It's inside approved list, and it has only requirement to JSON. You know the text.
That seems like part of the code, but if you could just drag it again and overwrite the entire thing.
Can you check
Okay.
if the ring HE folder has like the
Okay.
roundup sh and like a okay.
Yeah, the run is there. Okay, let's do that again, I guess.
Yeah.
Okay, and let's do that. Approve and replace. Oh, okay. Now it's gone. But why it was there, I'm not sure. Okay. Maybe I have copied it before it was broadcasted properly.
No worries.
Okay, makes sense. Yes. I think it should be there now, right? Oh no, it's not here.
I feel it might take like 10 seconds just because.
Okay, cool.
Yeah.
A small
nice,
question.
In the meantime, could you show your could you go for APIs again?
Yeah, for sure.
Real quick.
Yeah.
Yeah, APIs, ring HE, and look at the logs and see if. Yeah, just open this. and look at the end of it to see if.
Error file not found.
Okay.
Okay. Why is not found? Oh, again some. Okay, yeah. It's just
Okay,
hitting
so-
this one.
Yeah, I feel that something is bad about like the syncing of the files. So I think it's more like syncing everything.
Yeah.
Okay.
We could also do a manual install, but at this point, just
Okay, I think let's avoid that and just carry on. Let's not spend.
Okay.
I'll fix it later, I guess. But let's
Yeah,
carry on
if
with that
you
call, I guess.
want to just remove the folder from your APIs folder,
Yep.
so delete the ring HE and then just run this command. But SyftBox app install. This is.
Oh, this one? Okay, nice. Cool.
Yeah.
So now.
So.
Okay, I think it's done.
In the.
Yeah. Yeah, it's here again after installing.
Yeah.
Okay, nice. So should I check anything now? Yeah, it's here now.
Okay, let's see if it works because there were some errors. Like I think. Okay. Oh, you see that? Okay.
Yeah.
Great.
Private is there. Yeah. Cool. Let's share my screen.
Awesome. I will share my screen now. Okay, so I'm going to kick off the computation. Like to do that, I'm going to go to my data site, API data, and then the ring HE. And then I'm just going to create a new file here, data.json. And what I'm going to do is I'm going to just paste the list of participants I want to have in this data site. Sorry for these. So I'm going to choose this order of going around. So, and if you see, so that's the order. Like I'll go first. So the first person is going to be the leader. Like that's kind of how the app is designed. And once I do this, if we could all share our ring HE folder, because that's where, like you see that the file disappeared from this folder. Now it should be in, I think, Nezio's folder right now. And then, I don't know if it would have been, I forgot to ask everyone to share their screens, but I'll actually monitor your folder because after Nezio, it's going to end up with in this folder. So we should be able to see a file here and then it will disappear. Like I think so, sort of the flow.
Okay, I'll share my screen if that helps.
Yeah, just this folder is not actually just the ring HE folder.
So it's in the APIs, right?
Yeah.
Or my
in
data site?
Data.
My data site, right?
This data.json file that appeared here. This is what appeared in your data site, and it will disappear in just a minute. So you'll see that I'm looking at the in-between value, but then once it scratches off, like I think in the next sync, essentially it will say that, oh, this file is no longer here, because that's when it would end up in Shubha's folder, which...
In the interest of time, maybe we can wrap up in a minute or two.
I think it should be done like by the next couple of cycles of this. Either way, so the final result is going to be in API data, like back into the leader's data set, which is here, and we'll have a ring result. So we can see that it has disappeared from here.
My data site, it's on my data site.
Okay, awesome. So you see that the file has now appeared in Subha's data site here. And then once it disappears, like I'm the final participant, so it will come back into this folder, but then it will decrypt the result. So it will come up as data.json, but then it will remove that and publish a decrypted result, which is going to be the sum of that. While we are waiting for that, I think I just want to sort of stress that this is just an example of how the SyftBox network can be used, but this is by no means the only way to use homomorphic encryption or sort of add layers of privacy on top of this. And this also has a number of other components like the permission system and so on. So many sort of like it opens up an entire space of like, I think, creative ideas. But given that I think we'll be ending this soon, like I'm just going to wait for the result and then kind of end the thing. So I see that it's still in Subha's data side.
Also, for the participants here, we've been facing some issues with syncing today and yesterday, so we're still figuring out how we can solve it, and apologizes for the inconvenience. Some of you might have to wait quite a lot till like your syncing goes through. We're still figuring it out, so once we do, we're gonna like announce how you can fix it locally if it's needed on the platform.
Right. And one other thing while I was just having this, so you can see the different components of this. So the public key is actually being passed around in that data file. There is the list of participants, so you know who to send it to next. But then this is the current rolling data. That's sort of what we pass around, and as you saw in the slides. But I think I heard a thing on the chat.
Yes. So I raised my hand, and like just a small question actually. So I saw the entire YouTube video, and like it's like really impressive. But like this is possible only for the operations which are like linear or sequential by nature, right? So it's like x plus y plus z plus. Basically, the operation has to be linear. Let's say there are chunk of operation that happen together. Let's say A into B has to be done, then C into D has to be done, and then that has to be combined. So like, yeah, okay, understood.
That's a good question. So I think the short answer on that is, so when you have a fully homomorphic encryption scheme, you can do arbitrary computation. There is also a component of just networking, right? Like, so we might have to wait longer in the sense of like passing things around, but that's the short. Like this is addition is a simple operation. That's why I use a partially homomorphic encryption scheme. The HE scheme used is not even a fully homomorphic encryption scheme. But please ask these questions over the Slack channel just in the interest of time, so that everyone does have access to like showing their demo. Manik, maybe I can push this question to like just defer this to later, or like push it to Slack. Like if you want, I'll respond on Slack. I think you can see how the completion happens like over the video as well. Like I think, and if that's okay, then
I would suggest that maybe when the syncing will be done after the next presentation, you can share the result. Maybe just a
sure.
sec.
Yeah.
All right.
Absolutely.
Manik, if you don't mind, if your question is super quick, we can go that. Otherwise, we go to the next presenter. Either way is fine. Okay. Well, I guess we go to the next one. Brilliant, fantastic. Well, thank you, folks, for the presentation. Siddhant, do you have a question? Oh no, you clicked the wrong button. No, that's fine. Yeah, exactly. No worries. Yeah, I did that multiple times. Thank you. So the next presentation we have lined up is another very interesting project. I'm so very looking forward to see it, and it's a joint effort of many people. I don't know who's going to be presenting and if you're going to share the presentation like last week. So we have Siddhant, Ifra, Vrinda, Parth, and Irina also working on a FedRAG API. The floor is yours.
Yeah, sure. So maybe I'll give a rough level walkthrough of the entire thing. And then each other component, as it is a group effort, each other component has been isolatively developed, and the corresponding people can just take the stage from there, and they can present their own tasks. So just a second, I'll present my screen. I think it should be visible. Yeah. So what we were planning here is a sort of, so when I saw the aggregator app for the first time, the first thing that came into my mind was if we are able to collect a lot of information like locally around the entire client. So can we just in some way have a sort of search on top of the entire information? And what is better than an actual like retrieval augmented generation on top of the entire data structure data set that you're actually collecting. So the thing that we actually wanted to build was a sort of RAG pipeline on top of SyftBox to use its aggregation feature. But we also planned to put in homomorphic encryption directly in it, so that the embeddings or the vector spaces that are stored on the client side. So yeah, like it's just stored locally, and it's also as it is available in the public folder, it is encrypted, so no one can actually access it. So like this is how the operation cycle looks like. You have multiple users. Then you have the aggregator, basically, which takes in all the users' info, and how the info is collected and converted to the usable format will be talked by Rinda. Then we index it as a generic RAG setup. Then we encrypt it actually, and then each of the indexes stored individually on the client side. So every single person has its own vector database, and it's not taken on the person the person who is actually searching it. In the query mode, the person can just ask a question. His query also gets encrypted based on the key that is saved for each of the client, and then we retrieve top key values, and then the language model takes the corresponding text chunk as an input and generates out a response out of it. Yeah, so we have two flavors for generative model. So it's a local setup that will be shown by Irina, and then there is a global, like an online setup, which will be which is Gemini, which Ifra would present, and the entire UI was developed by Ifra. So maybe I think we can start with the data part first, the indexing and the data part, and Rinda would take it from there.
All right. So hi guys, I am gonna briefly explain the data cycle of the initial data cycle for this API we developed. Can I share my screen?
Yes.
Yeah.
Please.
Is my screen visible, guys?
Yeah.
All right. So just to get started, what you do is that you need to have a config.json in the public folder of your data site, which contains links to your GitHub profile, your LinkedIn profile, and your CV. Because essentially right now, this is the kind of data we're targeting personal info so that we can do like, a person search type of feature on top of the federated application. So what the API does is that we have a bunch of scrapers written down here for GitHub, LinkedIn, and CVs. When you run the SyftBox client, it's just gonna take all these links and extract all this information, scrape this, and put it in a bio.txt file, which stays on your own device itself. And yeah, I think I'll hand it over ahead. And this data is used further downstream for further processing.
Yeah, so once the bio.txt is computed, we basically have all the information required for each other individual person, and then what we do is basically we start indexing. So the indexing mechanism is like completely written from scratch, though we are using Llama index, but because we are also supposed to use an encrypted index here, right? So we cannot directly use Llama index. So even that part has been written in a custom way, and so like as my part continues, I'll maybe also talk about encryption thing. So Parth Nagar was working on encryption, but as he's not present today, I'll specifically mention about the part which he was, like basically the encryption part. So what exactly happened? We use Tenacity for this, and we basically once we have all the data and we perform all the indexing, we basically take all the indexes together and we iterate toward all the entire folder nodes, and we encrypt them using Tenacity, and that is stored alongside all the other actually available indexes on the local on the client side itself. And basically, and like this is also the part where encryption is coming in. So once you give a query to the system, it again fetches in the key from the client side. It encrypts that query with that particular key, so that both of them are like have the same shared key, and then both of these queries are together taken into account, and then we perform an encrypted dot product in the Tenacity itself, and basically then we fetch the top key values to get the retrieval outputs on our side. And obviously the language part like remains same, because once we have the index for the node, we can always pull in the data from the client side. And yeah, I think that is roughly the flow. And I think maybe I'll show my other screen, and Ifra can talk about the demo. So like there are some issues with Ifra system, so I'll be presenting the demo. So this is the Gemini setup. Yeah, Ifra, you can start.
So, okay, guys, so let me walk you through the Gemini setup. So, you can get your Gemini API key from the Google AI Studio and you can just plug it in here and then we can ask any query that you want. So, what do we want to ask? Okay, so let's
Maybe
see.
if you can also like explain
Anyone?
about sessions and like how the model selection thing and the
Okay.
metric part. Yeah.
Okay, so the model selection, you have two options here. The first one is the Hugging Face, and the second one is Gemini. Hugging Face is a local model which runs on Llama, and the second one that we have is the Gemini one, wherein you just plug in your Gemini API key and it pings the Gemini server and it retrieves you the output. And here we have system metrics to calculate your CPU and memory usage since everything is local, and you can save your sessions by clicking on the save snapshot button and it gets saved on your data site itself on SyftBox, and it's really private and nobody else has access to your chat history. So moving ahead with the chatbot, with the session name, it gets renamed on the very first query. Whatever you ask, it gets renamed according to it, and we even have a timestamp attached to it, and here your chat history would get displayed. And so can we get started with the chatbot, Siddhant?
Yeah, so we have like few people's data here because like anyways you have to create that config.json. So like the entire team has has its own data, and maybe we can like ask something like who works on PETs, and let's see. Yeah, so Parth works on PETs. Has anyone worked on interpretability? Yeah, and like you guys can put in more questions. Like I think most of you people like know Arena, and yeah, so you can put in more questions if you want, and I can try asking it.
Any suggestions for the question?
So it's like it also maintains the chat history, so it knows all the info. Yeah, so like that's on a very rough level what exactly the UI is. But okay, I think, is there a question? No. So yeah, like that is what on a very rough level the UI is, or it also like basically returns the corresponding folder name so that you can directly go and access that particular things. So but this is Gemini. This is so the entire idea of a privacy preserving thing is like you don't want to share anything onto a central server, right? So our idea on a very rough level was to remove any sort of paid service or any sort of centralized thing, and we spent a lot of time looking into local systems which are not heavy and like which can eventually run on your system without creating a huge amount of impact. So that particular setup, we were able to like do it to a certain extent, and that Irina would present.
Should I go now? Okay. Yeah, let me just share my entire screen. So I mean, it's the same setup you saw before. I'm just gonna showcase how you can ask questions using the local model. So maybe I just explain a little bit how it works going here. So we have like a pretty lengthy shell script in which we try to like set up Llama, who is gonna serve them all locally. So whenever we try to perform a query, it's gonna just like talk to the local Llama server and gonna perform our query. So not gonna go into details here, but now if I go here and I have Hugging Face, we have a default model. If I ask any question, we're gonna get answers not as good as Gemini, but I guess pretty decent. So I don't know who in my network knows computer vision. Gonna take a few seconds and then we're gonna see. Well, it doesn't always hit. Sometimes it misses. Trying it again, and the second one we see that it fetches Siddhant's email, and you can see my memory is pretty higher up compared to Siddhant's because I have to run them all locally. But that's pretty much it. there's any question.
I believe there was one question in chat. Something like, I know you answered already in chat. So will it answer private questions like what is someone's number? And Siddhant replied, those info is removed from collected data. So data that you index are pre-processed before that. Is this the way in which you retain privacy? Right, makes sense.
Yeah. So that was on a very rough level what we were trying to build, and obviously like there a lot of work has still to be done. For example, the model quality improvement is one of the next tasks, and we are also planning to like make this a sort of default environment for you, where unless and until you click on Hugging Face, you don't need to install Llama, because Llama is heavy on your system. So like we are working around those particular things now.
That's brilliant, fantastic. Yanizio has a question. Go ahead.
I have actually two. How difficult would it be to adapt that to different like models, like GPT or other ones? And second one is, if someone is trying to contribute, what they should do like in that specific order.
Yeah, so for the first question, it's like fairly easy to set up your own model. So currently we are like if you have the model already deployed on Hugging Face, let's say you have GPT-2 or Flan or any other model, you can just put in the model name. It will fetch it from the Hugging Face server and it will install it. So that is for Hugging Face, like because like Hugging Face is abstracted out everything. If you want to use Llama, which are like more generalized set of models with like larger weights, more, like better quality models, then you can. We also have an Llama integration, so you can directly fetch just like basically in the shell file itself. There is a single line which you can just add in extra, and that would do the remaining tasks for you. So it's just like Llama pull and whatever the name of the model that you need. And for contribution, I think we'll just like put the repo in public. So like I think it's already public now, but yeah, for contribution you can just take pull, make the changes as you like, and yeah, like just raise a pull request and then we can just merge it.
But I mean, like, is there a like roadmap of priorities that you have in mind, like the next like top 5 things that you think that would be nice to add to make it more robust or something like that?
Yeah, so first would be like actually so the first thing would be more tightly coupled UI. So currently UI has some issues here and there, and even the workflow has like few intricate issues because like none of us were like able to put a lot amount of time actually. But yeah, so that would be the first thing, fixing everything end to end so that like everything runs smoothly. Second would be basically use a better quality model to reduce hallucination. Third would be prompt tuning in some way, because it gives a lot of like random results in most of the cases. And I think fourth would be then actually in some way like so currently the entire info is fetched onto a single system even after doing homomorphic encryption, and the text info is still there. So what we're planning is to have a sort of like query mechanism onto the client system to just fetch in that particular amount of info and not pull out his entire text info back. So let's say he has 10 nodes. What like basically we get a query, we send the query to the client node. We basically fetch the retrieve node, and only that node gets returned out instead of all the nodes that are like matched. So like that is like extremely far off in future, but right now that is the highest priority. Like those 4 tasks. Fifth we are not decided. Maybe a bug that comes in and we have to resolve it.
Awesome.
Yeah, exactly. Yeah. Maybe. Also expanding on the data sources. Yes, we are like planning to put in more quality type of scrapers.
Later, if you, I mean, I need to go through the GitHub repository, but I would like to contribute somehow.
Sure.
So yeah, sure. I'll get in touch with you.
Someone. Manik, do you have a question?
Yeah, so before passing the context and the query to the Gemini, is it in encrypted form or in the decrypted form?
Yeah, so to the Gemini, it is meant to be decrypted. Otherwise, like how will even Gemini know what exactly is happening? And that's why we don't need Gemini altogether. We need a local model for that. And that's what we are actually working on, to remove Gemini completely out of the picture so that person can individually work just on his system. And once he fetches text, he need not to decrypt or encrypt or do like perform any sort of like privacy preserving operation on top of it. You can just put it in the system, because anyways it's your system and no info is going to be leaked.
Have you find any open source LLM that can do fully homomorphic encryption? The computation in fully homomorphic encryption?
I think that would be hard. For example, encoding text as a homomorphic encryption is like in itself messed up. And anyways, even if you send that text, like let's say there's a certain way in which you are able to perform some sort of hashing on top of text, and you put it in the like Gemini or something, it still won't make any sense to the model, right? Unless and until like we perform some sort of decrypting before it generates out the final results.
Okay.
Yeah, but like that's a cool thing to think about. Like if we could train a model, but like yeah, like okay.
Fabulous. Thank you so very much. That was incredible work. Brilliant indeed. Just like a huge shout out to all of you. Siddhant, Ifra, Vrinda, Parth, and Irina, of course, for these amazing showcase.
Also Hussam, he's not available today, but he was like he was another person who actually tested out the models.
Hussam, yeah. My apologies. Congratulations to all of you. That was very, very nice. Very well crafted presentation. So I now want to go to the next couple of speakers. I think we have Gustavo and Matthias talking us through the Netflix FL API. The floor is yours.
Okay, so I will just share a few slides and then I hand over to Matthias to give architectural view of the app. I'm just pasting now in the chat some comments if you want to follow along with the presentation. I hope it's easy to understand. Okay, let's go. Okay, so we are working on this Netflix app. It's something that was introduced by OpenMined team. I think they were giving us some hints, and it was really nice to choose to contribute on that because it's a real, I would say, private data that we can try to apply some patents on that. As I said, I'm providing in the chat these comments to if you want to follow along. If you do not have your personal data about Netflix viewing history, I think the app would use a dummy data. So it would run, but with this dummy data. And then we also have the link here for the dashboard that is now syncing and also the repository. So just to share a bit on how this data look like. So it's kind of a CSV file that you can retrieve directly from Netflix. It's not, I would say, a most complete kind of data, and it was one of the challenges that we faced during this past 30 days. So how can we use this not so informative data to come up with different insights using private enhancing mechanisms? And then in addition to that, and it's something that Matthias will detail a little bit more, is that we try to enhance a little bit this data, trying to provide different usages for that. So I will hand over to Matthias just to show about the architecture. Then I will present what we are running right now and about the dashboard.
Right. So yeah, thanks, Gustavo. And yeah, this has been quite an entertaining project. I think it has like a lot in it for like privacy technologies. So yeah, I mean, some of you might have seen this on LinkedIn already. This has been like quite useful in order to think about, how we get the data. So there are many different ways, as Gustavo mentioned, on getting your Netflix data. Right now, we're focusing on something quite simple, which is just what shows you watch and when, and you can easily download that. So I posted some instructions in the chat for that. But essentially, it's getting that data into your private folder, right? something really cool, since GDPR and other privacy policies have come in, is that you can request your personal data from many different services. So we have tested that with Netflix, and they have like quite a rich history of our account data and our profile data. So in the future we can also like work in order to integrate a more like enhanced view of our profile in our private folder. So yeah, essentially once we have that, we are into the SyftBox environment and into our application. And we move a developer will develop an application for us to run locally. And we divide it into two types of federation, right? So federated analytics, which is all about anonymizing data, reducing and enriching and aggregating, so making your data more anonymous, but also informative to give some signals in the aggregate. As well as we have federated learning models. In our experiments, we tested the SVD, so single vector decomposition recommendation engine, so that each participant will essentially fine-tune a global model, but they will also keep a user profile that they keep enhancing privately with their own ratings of the shows. So once all that gets processed locally, we use privacy enhanced technologies in order to, for example, like a differential privacy, in order to mask the analytics, and as well we can choose to do homomorphic encryption, which we haven't yet, but is a next step for any of the contributors that want to join. Well, there are some initial experiments, so maybe you can grow over them. But the idea is we will then write that into a restricted folder that only the aggregator can access. So this will already be masked and have some level of privacy to this analytics, as well as the model weights that we trained. The aggregator will go in and fetch all of that information and do its magic. We'll provide some dashboards. We'll fine-tune the general model. And there are other areas that we can think about privacy-enhanced technologies, such as incrementing more differential privacy, if you are planning to make these results more public outside of your community. I think that's pretty much it in terms of the artifacts. Then we'll get written back to a shared folder for the participants to go and grab the central model weights, or there's also like a TV show rich catalog that can be offered, so we can add more information, such as new movies, new actors, get the ratings from IMDb, so we get a general idea, richer, let's say, item catalogs for our data. In that way, keep iterating the model as the ring goes through. So yeah, I think that's pretty much it. We can move into questions later on. But first, I'll send to Gustavo for a showcase of that.
Yeah, thanks, Matthias. So I will just share right now our current dashboard. So, and then I'll try to explain a little bit in details this first part, and then we can go, if we have enough time, we can go through the code and just to explain the architecture. So I think would be an introduction for everyone that wants to contribute and jump in this use case, because I think we have the data. It's really difficult to get participants, but we have some. And then if you have additional ideas and you want to try on this data, it's more than welcome to join forces with us. So right now our dashboard is running as a static file being generated and available in SyftBox. This first insight that we are deriving here, it's about applying differential privacy or local differential privacy on the viewing history of participants, and then aggregating all those differential privacy data on the aggregator side, and then listing here the top 5 TV series. One thing that we decided during this use case, it was to restrict only on series. Another option that it's available, it's to work with movies, and it's open if you want someone have an idea to jump in and contribute on that. Right now we are using data of 5 participants, And here it's the SVD part that Matthias explained that is being reported. Let me share about this so I can give a bit more of detail on this use case about the top 5. Let's go back here. Okay, so let me just move. Okay, so here it's on the user local data site. So here we are providing this sparse vector that each index represents one of the series. And then we have the number of episodes seen by each series here. So it's a very sparse vector. Currently, our dictionary about series is around 2,000 TV series, so it's very sparse data. Then we applied this local differential privacy to this vector, and then this vector is the one that is shared with the aggregator. Right now, we are considering a minimum of 3 participants to do the calculation. And then from this calculation, we only report this top 5 series that is being used for the generation of this static page. Okay, I don't know how we are on time. If we can just have a quick look on the structure of the code.
I'd say we have 3 minutes.
Okay, just I think I can share really quick here. I think one thing that is different, I don't know, I'm not familiar with all the user cases, but it's something that we did here. I think it's a bit nice. It's because if you take into consideration, for example, the CPU tracker, that normally you have a repository for the aggregator side, a repository for the participant. And here on our Netflix app, we are doing a bit different. Now we have this participant code. So all the application, it's part of the repository, and also the aggregator code. The only difference here, it's made on the main.py that we check for if you are an aggregator or not, and then it chooses which part of the application will be running. I think the README from the repository it's up to date. So I think if someone wants to try and use your own data, because there are some tweaks that you need to do on the environment to use your data, and also I think you can reach out through the Slack and we can talk about that. We can have a walkthrough 101 on that. Yes. Thanks so much. Thank you everyone for the support. Thank you OpenMined team, because I did a lot of questions and also all the people that I had some exchange to understand a bit better and a lot of insights. And I learned a lot during these past 30 days, and I hope to keep contributing and learning with all of you. Thank you.
Amazing. Thank you. Thank you very much for the presentation. That was brilliant and very, very cool application. I was keen on installing the API, so you should see myself popping out at some point as an extra participant, and I recommend doing the same to all of you. All right, so now we have, for the next 10 minutes, we have 2 quick updates / announcements of other activities that this wonderful community is working on. I would go for Siddhant first. He can go us through his project he's working on. He said he's very early stage, but very glad you could share to the community. I would say, Siddhant, if you can stay within 5 minutes, so we can give Lucas the time to give his updates as well.
Yeah, sure. So maybe I'll give a rough level overview of the project, like in 30 seconds, and maybe then Monica can actually present the entire thing and the flow and everything. So one of the reasons why we started building this is because you guys already saw the demo which Samir gave. It's like a sequential architecture, and we thought how is there a way in which we can perform these clustering sort of thing, basically something like a baud mass or some sort of more complex operation which cannot be done sequentially. And hence this particular thought came in our mind that instead of let's not use fully homomorphic encryption completely, let's use only PHEs, and let's try to make an architecture in such a way that just by using PHEs and key sharing, we do this entire communication entire computation end-to-end without actually sort of leakage of information. So yeah, that was a rough level idea of what we actually thought of, and Monica and Upsal are working alongside with me. And like Monica is leading the project, I'm just a side hand because I'm not very good with these type of things. But yeah, just learning things on the way. Yeah. So Monica, I think you can present your screen and you can start.
Sure. Thanks. So I'll just like quickly show you. First, we designed a two-party protocol. I hope you can see this. Sorry for very poor presentation skills. So we thought there are two parties who want to just compute order of operations where they want to do division, multiplication, addition, and subtraction. So they'll hold a bunch of ciphertexts with each of them, and obviously PHE schemes can't do all these operations. So, for example, Parier can only do addition, and Elgamal can only do multiplication. So we thought, how about combining these two? It's really not that easy to actually mix two PHEs because Elgamal works in a completely different ciphertext space, and Parier it works in a completely different group. So our idea was to use a bit of randomization midway to obfuscate the ciphertext and perform decryption midway, and then apply operations such as like Parier can do addition and scalar multiplication, and Elgamal can do full multiplication on homomorphic ciphertext. So we are going to combine those two. So I'll just show. I'll show you the scheme how it like looks on application level. When we are doing it in a federated manner, what we have is, so I said we need to do some sort of randomization. So for that, we require a randomizer, and these M's represent multiple parties who want to do multiple operations. So somebody holds an additive ciphertext, somebody holds a multiplicative ciphertext, and we need two key persons. One is Parier and the other one is Elgamal. They'll generate the keys for encryption and decryption. And aggregator is the one that actually combines these operations together and also generates random ciphertext to obfuscate, random numbers to obfuscate the decrypted ciphertext. So this is kind of a high-level overview, and it's still a work in progress. I hope I was like not too vague, but also because we are running short of time, I just try to rush through it.
Thanks. That's very cool. I just want to rephrase that. This is an effort of Siddhant, Monica, and Upsal as well, I believe. So, and you're open for contribution, aren't you? So if there's anyone willing to join this group, and I've seen a message going on Plaza actually the other day, someone wanting to dig more into these techniques, please feel free to do so, and use Slack for that. We're very happy to facilitate this sort of activities on our community. This is absolutely fantastic. Amazing. So thank you very much for your updates, and the next presenter is Lucas, I believe, and we have updates on e-voting poll. Lucas, are you with us?
Yes. Sorry. Sharing my screen, and I also suffering from a bit of the syncing problem. So what I'm showing you from here is a local version, but I keep working on this throughout the day, and so I'll try to make sure that the updated version is on. I try to be very, very quick. I just update the interface and also information on the votings. So what we have now is that the slider is more it's more meaningful for the rated voting, because we have the 50-50 on the center, or we have 100-0 or 0-100. Also here on the information we have the date. So we have for creation and last update. We also have the public metadata of the election here. And in votes, we have like an interesting thing, because if you have less than 3 votes, it's easy to know which votes is from the participants. So what we did here is like we put on red this this value if it's less than 3. And we show this message that at least 3 votes are required to aggregate the outcome of election. We do not aggregate if it's less than 3. However, if it's greater than 8, it right now it's not showing the voters because it's the old JSON that did not have include the voters, the participants. So in future versions, I will make sure that this JSON is available. But it also show the created of the election and cutting trimming the email. So we have just the handle. Another thing is that here in About, in Lucas Lopez, I have my personal website, and here in 30 days of federated code, if you click, you can. I invite you to go in the timeline of my progress. I invite you to also check the LinkedIn post because it have more information on what was done. And yeah, it's a little bit out of syncing, but I'll make sure that these will have all the updates that I'm planning to do today. Last thing, the participatory bulletin. So the thing is that we also have the how to use, and the how to use now for installing is very easy because we have like this SyftBox app install command that makes everything easier. What I'm intending to do here is to actually have the same structure of elections, because if you understand the election, we have like the election is the structure and the slider value is the vote. Here in participatory bulletin, we will have the same thing, the structure that we have here, like and it's hierarchical. I'm sorry, I will improve the style here to make sure that it's easier to show. But once you navigate here, you can see all these sliders. So these sliders could be adjusted by the users and aggregate the votes, and the structure itself of the hierarchy of the projects, and also the ranking, because here you can ranking the projects. This would be the election. And I also would like to put a tree visualization, so we can see all the bullets going from the truck, like all the flows around the sub projects. So that's what I intend to do, and I'll try to keep posting, like updating here. And I think that's it from my presentation. Thank you.
Thank you, Lucas. That was super cool. And I'm really glad to see this getting together. Like from the last presentation to this one is already super cool. Amazing. I think we're at time, and miraculously we did on time. So well done, everyone. And thank you very much for this very insightful presentations. It was an awesome session, and it wouldn't be awesome if it was not for your contribution. So thank you so very much, sincerely, for participating and for willing to present your amazing work you're doing. This is it for the show and tell SyftBox session for today. Thank you very much for joining, and I hope to see you soon around. Bye, folks.
Thank you. Bye bye.
Thank you so much.
Thank you, everyone.
Bye. Thank you. Bye.